right? So now we finished the last 10th MCQ. So very easy, you know. So physical chemistry as well as the chemical calculation is actually the easiest part where you can score easily, right? But the problem is once you're doing MCQ, there will be a time consumption there, right? So there is only around 3 MCQs, I think so. So around 3 MCQs are there, means you can finish them up, right? So we have 3 MCQs in each of these cases, and maybe three. Yeah, you have 3 MCQs. Right, now we'll go to the next question. So we have 27th MCQ, right? So 27th is again physical chemistry. 27th MCQ, which is physical chemistry. So I have physical chemistry here. So this comes under solubility product. Solubility product. So this is the subheading that you have. So I think you guys know KSP. So it comes under KSP, right? Let's see the calculation MCQ. The solubility product of ionic hydroxide MOH twice at room temperature is 510 to the power minus 10 mole cube decimeter minus 9. The OH minus 9 concentration in mole decimeter minus 3 of a saturated solution of MOH twice at room temperature. Okay. Now they have given the KSP of the MOH twice, which is the hydroxide of this solution, which is 5 into 10 to the power minus 10 mole cube decimeter minus 9. Mole cube decimeter minus 9. Okay. Now they are asking the hydroxide's concentration, right? They are asking the hydroxide concentration in mole decimeter minus 3 of a saturated solution of MOH twice at room temperature. So now the particular solution is at room temperature. Okay. In this part, you have to be careful. Ionic product, if you write the ionic product for this, so MOH twice solid, right? This solid undergoes partial dissociation, giving M2 plus aqueous plus 2OH minus aqueous. So this is the dissociation case. If some amount of MOH twice is dissociated, let's say S amount, and here some amount of S will be formed, and here 2S some substance will be formed here, right? Some 2S amount of substance will be formed here. Now once you are running the ionic product, so ion product, right, IP, ion product of MOH twice is equal to, here I will say most of you will get confused here. What is ion product and what is KSP? Right, there will be same thing, right? There will be a problem here. I'll explain you why. So M2 plus aqueous into OH minus aqueous, the whole thing square. But once you write the equation for KSP, you will get the same thing here. So KSP of the solution MOH twice, right, is equal to M2 plus aqueous into OH minus aqueous, the whole thing square. See here, same thing is being applied here, but the thing is, this ionic product and this KSP will not be same always. Always it won't be the same. You have to keep this thing in mind. Now, let's say I'm taking a graph, just like a graph. So let's say I'm having my KSP of the solution of MOH twice over here, right? Let's say the MOH twice solution is over here, the KSP. What I'm going to do is I'm going to take some amount of M2 plus aqueous, right? Let's say M2 plus aqueous is there in a solution here, right? You're going to have M2 plus aqueous solution here, some amount of M2 plus aqueous. What I'm going to do is I'm going to take a strong electrolyte, let's say NaOH, a strong base. I'm going to add drop wise. So once I'm doing this, I'm going to write the ion product here. Let's say I'm going to have let's say 1 into 10 to the power minus 2 mole decimeter minus 3. Let's say I'm having this amount of moles here. When this amount of moles is here, what happens is this will form some amount of precipitate. Is it? No. Once I'm starting to at the base, it will start to form. It won't form any precipitates, right? It won't form precipitates unless so until, right? I'll be keep adding it. So in this way, the OH minus concentration will increase, right? I'm adding the concentration. As a result, what will happen is, right? I'm increasing the concentration of OH minus. As a result, the ion product will increase. So let's say my IP is right now here. Did the precipitate start? No, still not, because M2 plus is also there, MOH is also there. There's going to be a partial reaction over here. Understood? So there will be a forward reaction, reverse reaction. So therefore, all these will be equal. It will be under equilibrium. So I'll just keep adding OH minus concentration up to a point where I will reach to the point where the ion product will be equal to KSP, which means when this ion product is equal to KSP, it has just become saturated, which means if I add one more drop, the precipitate will be started there. It has just become saturated. For example, you take some amount of water, right? You take some amount of water, keep adding salt, like let's say salt or sugar, keep mixing them up. Add one teaspoon each and every time, then mix until it has to completely dissolve. There will be a point, once you add some amount of sugar, it will not dissolve. But what you will do, some of you, what you will do, you will go heat them up. So due to the heating, sometimes what will happen, some amount of sugar will dissolve. Then if you add some more sugar, then what? Nothing will be actually dissolved there. So that is a maximum amount of sugar or salt that can be dissolved in the water. So that is what you say saturated. So it has completely been filled up, the space in between the water molecules. So that is called the saturation. So it's completely saturated. So it has just become saturated at this point. So when it becomes equal to ionic product, when KSP becomes equal to ionic product, here from this point it has just become saturated. Keep in mind, it has just become saturated. Just become saturated. If this one has just become saturated, it means you can consider two instances. One, you can consider the ion product may be less than KSP or maybe more than KSP. What I am going to do is, I have taken, it might just start precipitated, right? So that means I'll say like ion product has just reached the saturated state. It can be saturated or not saturated. That is the instance where ion product and KSP can be equal, right? It has just become saturated. Okay. So at this instant, I will consider the KSP of this two to be equal to ionic product. So KSP of this substance is going to be equal to this case here. Understood? So there is a thing here, right? Now let's go to the calculation part. Hope you guys understood here. Right? Over here, right? Come to this part. So they have given the we have took all this part. Now we need to find the concentration of this thing. So you need to find S. How much is the concentration of S? So this is the concentration. Don't forget this. This is in moles. So this concentration. So 5 into 10 to the power 10 mole cube decimeter minus 9 is equal to S mole decimeter minus 3 into 2S mole decimeter minus 3, the whole thing square. So what you will get is 5 into 10 to the power 10, right? 5 into 10 to the power 10 mole cube decimeter minus 9 is equal to, here 2s means 4s squared, here you have another s, so 4s cube. So 4s cube. So if you bring it here, you will get right, yeah, s cube is equal to 5 over 4 into 10 to the power 10. Is it 10 to the power minus 10? Yeah, it's minus 10. My bad. Minus 10 here, right? 10 to the power minus 10. Okay. So S is equal to 1.25, right? So 1.25 into 10 to the power minus 10, the whole thing cube. So S is equal to, if you bring this two decimal points over here, you will get 10 to the power minus 12. So square root 125 into 10 to the power minus 12. So S is equal to 5, right? 5 into 5, 25. 5 into 25, 125. So 5 into 10 to the power, this is cube. So 5 into 10 to the power minus 4 mole decimeter minus 3. Now they are asking the concentration of OH minus. So OH minus concentration in saturated case is actually equal to 2S. That's the thing, no? So they are asking the concentration of this case, 2S. So which means 2 into 5 into 10 to the power minus 4 mole decimeter minus 6. So minus 3, which is equal to 10 into 10 to the power minus 4. So you have, yeah, 10 into 10 to the power minus 4, which is equal to 1 into 10 to the power minus 3 mole decimeter minus 3. So this is going to be your answer. So what answer you have? You have the second answer here, right? Second answer, right? The thing behind this question is, when ionic product is equal to KSP, it has just become saturated. That's the main thing you have to know. In a saturated solution, the amount of OH minus and M2 plus in this case scenario is actually completely filled up. So it is at the verge of precipitation, right? It is at the verge of precipitation. So which means you need to know when it is at the verge of precipitation, there the ionic product must be equal to KSP, right? That's the main thing you have to know. If it exceeds the KSP, if the ionic product exceeds the KSP, precipitation will take place. But if the ionic product is less than the KSP, there will be no precipitation taking place, right? There are lots of example questions that is there in the resource book. Follow them up, everything will be clear, right? Those who have doubts can drop me a message privately under my Telegram channel or in the WhatsApp group. So we will do the next question, right? Which is actually the 31st, right? So we'll see you in the next video.